I'm happy to welcome you to this SS1 chemistry revision. In this session, we will cover essential topics, providing clear explanations and step-by-step solutions to key problems in order to help the students to excel in their examination ahead. Let's begin. Topic 1. Atoms, molecules, and ions. An atom is the smallest particle of an element that retains its chemical properties. Atoms combine to form molecules. The key difference between an atom and a molecule is that an atom is a single unit, while a molecule can be a unit-stable atom or of two or more atoms chemically bonded together. Atom can be independent or dependent, but molecules are independent particles. Ions are charged particles formed when atoms lose or gain electrons. They have two main characteristics. 1. They carry an electrical charge. 2. They can exist as single atoms, like sodium ion, or groups of atoms, like trioxosulfate. 6. Ions. Cations and anions are two types of ions. A cation is a positively charged ion formed when an atom loses electrons, such as sodium ions. An anion is negatively charged, formed when an atom gains electrons, like chloride. Now, let's write the electronic configurations of some common ions using the SPDF notation. Chlorine atom, Cl, the atomic number is 17, is 1s2, 2s2, 2p6, 3s2, 3p5. But chloride ion, Cl- is 1s2, 2s2, 2p6, 3s2, 3p6. Do you notice the difference between the electron configuration of chlorine atom and chloride ion? 3p5 for chlorine atom, but 3p6 for chloride ion. This is because it gains one more electron. Calcium atom, Ca, the atomic number is 20, is 1s2, 2s2, 2p6, 3s2, 3p6 for s2. Calcium ion, Ca2+, is 1s2, 2s2, 2p6, 3s2, 3p6. This is because it donated two electrons. Sulfur atom, S, the atomic number is 16, is 1s2, 2s2, 2p6, 3s2, 3p4. Sulfide ion, S2-, is 1s2, 2s2, 2p6, 3s2, 3p6. Note that Aufbau's principle states that electrons fill atomic orbitals in order of increasing energy levels. Hund's rule states that electron enters to generate orbitals singly before pairing. Pauli exclusion principle states that no two electrons in the same atom will have the same for quantum numbers. This means electrons' position in an atom is unique. Do you know about isotopy? The existence of atoms with the same atomic number, which means same proton number, but different mass number due to differences in neutron number. Isotopes are atoms of the same element with different numbers of neutrons. An example is chlorine, which has Cl35 and Cl37. We can calculate the relative molecular mass of an element from the average weighted masses of their isotopes, based on their relative abundance. For instance, if chlorine 35 is 75% in abundance and chlorine 37 is 25% in abundance. To calculate the relative atomic mass of chlorine will be 35 times 75% plus 37 times 25% equals 26.25 plus 9.25 is equal to 35.5. Try it again by yourself. Master this. Topic 2. IUPAC nomenclature and oxidation numbers. The oxidation state of an element is the charge an atom would have if electrons were completely transferred. It is the atomic charge number of an element in a compound. In H2SO4, sulfur has an oxidation state of +6, while in SO2, sulfur has an oxidation state of +4. This shows that sulfur has different oxidation state numbers in different compounds. Now, let's name some chemical compounds using epoch nomenclature. Fe2O3 is iron 3 oxide. KClO3 is potassium trioxochlorate 5. Therefore ClO3- is trioxochlorate 5 ion. CuSO4 is copper 2 tetraoxosulfate 6. NH for NO3 is ammonium trioxonitrate 5. Therefore NH for plus is ammonium ion. Can you write the chemical formulae for the following compounds? Sodium trioxocarbonate 4. Magnesium hydroxide. Iron 3 chloride. Aluminium tetraoxosulfate 6. Topic 3. Separation techniques and mole concept. Common separation techniques include 1. Filtration. Separating insoluble solids using filter paper. The mixture that passed the filter paper is called the filtrate. The mixture remaining in the filter paper is called the residue. 2. Distillation. Used in separation of solvents or fractions of mixtures with different boiling points. 3. Crystallization. Used in recovery solutes that form crystals and are thermally unstable. 4. Decantation. Used in separating insoluble solids in a haste. 5. Chromatography. It works based on the principle that different substances move at different speeds on a medium due to their varying solubilities. Let's talk about mole. The mole of a substance is the amount containing Avogadro's number of particles, 6.022 times 10 raised to the power of 23. Let's try mole calculation using calcium trioxocarbonate 4. The relative atomic mass of calcium is 40, carbon is 12 and oxygen is 16. To determine the moles of CaCO3 in 10 grams. Molar mass equals 40 plus 12 plus 16 by 3 equals 100 grams per mole. Moles equals 10 divided by 100 is equal to 0.1 moles. To find the number of moles in 8.8 grams of CO2. Molar mass of CO2 equals 12 plus 16 times 2 equals 44 grams per mole. To get the mole, moles equals 8.8 divided by 44 is equal to 0.2 mole. Empirical formula is important in the examination. For the empirical formula of a sodium compound containing 23 gram of Na, 16 gram of O, and 1 gram of H. Do this. Moles of Na equals 23 gram divided by 23 gram per mole equals 1. Moles of O equals 16 gram divided by 16 grams per mole equals 1. Moles of H equals 1 gram divided by 1 gram per mole equals 1. Since all the values is 1. Thus, the empirical formula is NaOH. From Na1, O1 and H1. Now, for a compound with 40% carbon, C, 6.67% hydrogen, H, and 53.33% oxygen, O, and a molecular mass of 90. Moles of C equals 40 gram in percentage divided by 12 grams per mole. Approximately 3.33. Moles of H equals 6.67 gram in percentage divided by 1 gram per mole. Approximately 6.67. Moles of O equals 53.33 gram in percentage divided by 16 grams per mole. Approximately 3.33. The empirical formula is C1H2O1, and since its molar mass is 90, the molecular formula is C3H6O3. Do you know how? Topic 4. Kinetic theory and gas laws. The kinetic theory of matter states that particles in matter are in constant motion. As temperature increases, the kinetic energy of particles also increases. Boyle's law states that pressure and volume of a gas are inversely proportional at constant temperature. Remember the song. For a gas with an initial volume of 60 cubic centimeters at 1.5 atm, if pressure is increased to 3.0 atm, the new volume is V2 equals P1 V1 over P2 equals 1.5 times 60 over 3.0 equals 30 cubic centimeters. Try Charles' law questions 2. Graham's law of diffusion states that the rate of diffusion is inversely proportional to the square root of molar mass. For gases A, molecular mass equals 16, and B, molecular mass equals 64. Therefore, rate of diffusion equals square root of 64 over 16 equals 2. This means gas A will diffuse twice the rate of gas B at constant temperature and pressure. The higher the molar mass of a gas, the slower it diffuses. The difference between relative atomic mass and relative molecular mass is that atomic mass refers to a single atom, while molecular mass refers to a molecule's total mass. Topic 5. Chemical equations and balancing. A chemical equation represents a chemical reaction using symbols. It must be balanced to obey the law of conservation of mass. Balanced equations. Aluminium Al combines with oxygen O2 and becomes Al2O3. The balanced chemical equation is for Al plus 3O2 becomes 2Al2O3. Iron Fe combined with chlorine gas Cl2 and forms FeCl3. The balanced chemical equation is 2Fe plus 3Cl2 produces 2FeCl3. Ethane, C2H6 burns in oxygen O2 to form CO2 plus H2O. The balanced chemical equation is 2C2H6 plus 7O2 becomes for CO2 plus 6H2O. Reaction of sodium hydroxide NaOH with tetraoxosulfate 6-acid H2SO4. 2NaOH plus H2SO4 becomes Na2SO4 plus 2H2O. Reaction of silver trioxonitrate 5-AgNO3 with sodium chloride NaCl in a precipitation reaction. AgNO3 plus NaCl becomes AgCl plus NaNO3. In conclusion, don't forget that atomic number Z is the total number of protons in an atom's nucleus. This means the proton number is the atomic number. Also, recall that mass number or atomic mass A is proton number plus neutron number. This revision covers atoms, molecules, ions, electron configurations, separation techniques, gas laws, and balancing equations. Understanding these concepts is essential for mastering chemistry. And this will prepare you to pass your Chemistry SS1 exam in SFC. Keep practicing, and best of luck in your exams.